Yes, sir. Of course, it is visible.
ISRO,
mute unmute sound
many
increase
government
decrease
bodies, PWD, NHI. So we are the one got approval because it needs lot of testing to be done.
அது என்ன
These
சர்ச் பண்ணி கேட்க
testings
முடியாது
are mentioned
மீட்டிங்
in
போயிட்டு
IS
இருக்கு
1393
சர்ச்சில்
and
போய்
British standards 4447. So accordingly,
ஆமாம் தான்
we
அதில்
have
போய்
conducted lot of
என்ன
testing
கொடுக்கணும்
for your anchorages, and we have been continuously doing these testing
மைக்னா
for IT
வெப்புக்கு தான்
Madras. With
இன்டர்நெட்டுக்கு
the
தான்
help
போகுது
of IT Madras, we could able to perform these tests. So
அதில்
we
போய்
are
மாற்றணுங்களா
maybe we are one of the best in the pre-stressing industry. So far we have completed more than 2,500 buildings, working with almost all the structural consultants in India. So let me start this for the students. So we all started from scratch, like Stone Age. That is the first house, first shelter. From there we invented cement, mortar, steel, and right now we are struggling to manage our living space, our working space in the concrete jungle. Slowly we are trying to occupy wherever space available in the metro trying to utilize the space available, and since we don't have enough space to horizontal widening, so we try to go vertical, increase in the vertical space. So in that process, we found, maybe in the year 1952, Mr. Adrian Francis from Paris, from France, who invented this technology, the pre-stressing system using high tensile wires. Pre-stressing system is nothing but alternate method of reinforcement in the concrete, that is called the pre-stressing. You induce the stressing force into the concrete member, so that the concrete member will be ready to take care of the loads to come over that element of the structure. So in pre-stressing system, there is two application procedure. One is post-tensioning and another one is pre-tensioning system. In post-tensioning also, there are two materials, different types of materials to be used. One is bonded PTC, another one is unbonded post-tensioning system. This might be the first pre-stressing element in the world, in the society, because the first one is very easy and simple example. There are steel fans covering the container which can take care of oil or grains, food grains, anything, even wine also. So once it is empty, it will be as it is, it will be in its position. But once some pressure comes in, the wooden planks will try to buckle, but the steel straps will not allow, because steel straps is given to take care of that load. So this is a simple example of pre-stressing structure, because you keep some steel member which can take the load to come. It will take care of that load. So like post-tensioning, you are inducing the stresses, you are inducing the forces against the stresses resulting from the external load, like live load, which will come on a later stage, but you induce the force, so the load comes, it will take care. In post-tensioning, that inducing will take place once the concrete gets its desired strength. For us, that desired strength is 25 Newton per millimeter square. Whereas in pre-tensioning, that inducing will take place prior to concreting, and once concrete motor and concrete gets that 25 Newton per millimeter square. You cut the strands, because of the bonding, the stress will pass on to the structure. And this is a simple picture will show how this pre-stressing system is superior than conventional reinforced cement concrete system. This is the material which makes all the difference. It is the elastic material, the high tensile strand. The capacity is 1860 Newton per millimeter square. Whereas you compare to Fe 500, the strength is 500. Fe 500 generally we are using. So the strand is almost 4 times greater than the conventional reinforcement. So we are replacing the reinforcement, not completely, partially we are replacing the conventional reinforcement into this special steel. And it is an elastic material. So now coming to this, see, once the load acts on any beam, there will be a deflection. And you see this deflection, there is a parabolic curve. It will happen because the deflection is the maximum at the center span. So when ordinary conventional steel, it is a treatment steel, you can have only the L at both ends, you have to keep it straight. In the left side, you can see there are bottom reinforcement provisions. Whereas in the right side, since it is a elastic material and you can lay accordingly as per your bending moment requirement, accordingly your deflection lined up. So once that is laid inside the concrete, once you stress it, once you stress it, you apply force to that member, there will be a hogging effect, there will be a uplift. So once load comes into that, there will be no deflection at all. Or when compared to conventional system, there will be very minimum deflection. Like in the pre-tensioning, you tension the strands, the HD strands, and you pour the concrete, maybe in the form of girders or beams. You cast it, and once the concrete achieves 25 Newton per millimeter square, and you cut the strands with the bonding, it will try to move inside, and then there is a uplift occur. There will be a uplift hogging happening. So with that, you can eliminate deflection. There will be literally, when compared to conventional system, it will behave very good in controlling the deflection. And where and all you can use this post tension in wherever you want, you can use the post tensioning. Large column free space, you want a heavy, faster construction, and you want to construct for heavy loads. You will have better architectural freedom in this, because you will have almost a flat slab when compared to conventional system. So this allows you to have much better working friendly structure. And some components you need to implement this post tensioning work. One is Strand, I said it IS 14268 IS code governs this material. In India, we use in 2 diameters. One is 12.7 millimeter dia, and another one is 15.2 millimeter dia. The capacity varies. The 15.2 millimeter dia, the capacity is 260 kilonewton. So roughly about 26 ton load one strand will take, and 12.7 is 18 ton capacity. And you need some sheathing, the conduit material you need, that generally available in cast iron and HDPE for mostly in the bridge projects, you might be seeing this HDPE sheeting, because this is very easy to lay, and corrosion protection also up to some extent. This will help to protect the strand. So these two materials will be used for conduits. This is multi ducts laid in beams. And other components like anchorage, we call it as anchorage. You can see in the picture there are guide cone, castings, and wedge plate, wedges. These are all the components you need to execute the post tensioning works. Generally, the major portion in the bridges and all, you need large force to be transferred to the member. So the strand unit will be huge. Whereas in buildings, since your slab element will be from 180 millimeter to 300 millimeter, your slab thickness will be. So there, the flat anchorages will be used. You can see the picture. This is called the flat or mono anchorages. You can have 5 strands in one conduit. Approximately 70-ton load can be transferred to with one anchorage, with this one unit. And some of the equipments you need this to execute this technology, dispensers and bulb machines, and you have to use hydraulic equipments, hydraulic stressing jacks to transfer the force to the member, because you have to pull, you have to stress the strands. Then only the load transfer to the concrete element. So you need some special equipments like jacks, pumps, and you can have tendon units from 5 numbers to 56 numbers. 56 numbers means there are huge force. So maybe spans about 60 meters, 70 meters span bridges needs those heavy capacity anchorage units. And you need some ground pump, because after applying the force, after the stressing operation, you have to protect those strands for its lifetime. So cement is the best corrosion protection material available all around the world. So by using cement, you have to grout those pipes, those ducts, இப்ப கேக்குதா? கேக்குதா? Okay, okay. Thank you. Okay. Sorry, audio is interrupted. So this is, we did for Chennai Anna Centenary Library, there is no support for about 140 feet span. And it is at the top of this level. See, you can see there are elevation differences at frequent interval. It is like open air theater on the above level, and the lower level it is a fantastic auditorium without any support. So this is possible because of PT. And one more fine example, a hotel project in Pune. You can see there are only huge columns at lower level, and above that there are 8-9 stories. It's a hotel building, so the columns are very closely located, and this particular transfer girder is a PT, post tensioning girder. So because of post tensioning, the huge column loads are taken care. Generally, we do design and execution of video. As a post tensioning company, we have got a very strong design team. People are from IIT Madras and IIT Mumbai, so they work together with us, and we design all the horizontal members of the projects we involve. All beams, slabs, girders, we used to design, and we work hand to hand with the structural consultants, because ultimately they are the responsible people for any structure. So we work with them. We work with the structural consultants along with the architectural requirements. So we do design and we release drawings, framing, that means form of drawing we release, and reinforcement we used to design. We release those reinforcement drawings as well, and the post tensioning layout, tender layout drawings. So it is our responsibility as a post tensioning vendor. We do all this. And while coming to sequence of work, is only laying, stressing, and grouting. It's like in this situation only we come into the project for execution. Once you start the reinforcement work, we come, lay our ducts, cut our strand, thread into that, and we make some arrangements. There is a bulb end arrangement, anchorages, live and fixing, and it varies from building. This is, in buildings we do this, and in bridge projects like in segmental construction and all, we do like this. We make a 3 meter or 2.5 meter segments, the entire span cut into 2 meter segments, and we make like this. On girders, we lay the tendons like this. Is a high girder. You can see, the parabolic shape. It's low at the center of the span, high at the supports. So in girders it will be like this, and in tanks it will be like this. In the blisters, where you stress in a very closed location, it will be like this. And in buildings, generally tendon length is we maintain roughly about 30 to 35 meter per tendon. That means each tendon will have a length of 30 to 35 meters, and we stress from one end. The another end will be embedded inside the concrete. That will act as the dead end, we call it as. That will be part and parcel of the concrete, and the other end through live end, where we have written live end, through that we used to stress. And once the laying completed, we can go out with the concreting, make sure everything is in place. And during concreting, we have to make sure no one disturbs these tendons. And also we used to mark with the paint mark, so that once you remove the formwork, you'll be identifying your exact duct tendon location. So we used to make a paint mark as well. So some of the points we have to take care during concreting or any post-finishing slabs or beams. The compaction of the concrete is very, very important. Minimum concrete grade required is M35. The 35 MPa should be your lowest concrete grade for any post-finishing structure. And the bursting steel position test, I think we'll take care. Then once the concrete gets 25 MPa, that is 25 Newton per millimeter square, we can do the stressing. Stress is nothing but load by area, and whenever you do stressing, you can measure the strain. Strain is change in length by original length. So once it is an elastic material, so modulus of elasticity is stress by strain. So once you are applying stress, you can always measure the strain as well. So each and every strand to be measured for its elongation, for its strain. That will make sure that your operation, your stressing operation, what you are doing is correct or wrong. Because there are many codal provisions are there. Indian codes allows for plus or minus 5% deviation, whereas international codes allows up to plus or minus 8%, because that is very important. Because here in any post-tensioning structure, strand is the effective steel. Conventional rebar is a passive steel. So all the force transfer will be taken care by only strand. So the stressing activity is very, very important. You can measure the elongation strain in each and every strands, so that we make sure that designed force has been successfully transferred to the member. So you need some exposure, you need some experience to know this, to adopt, to execute this technology. As I said, it starts from 5 strands to end up with 56 strands. So there are huge jacks available for multi-strand, and this is the picture taken in the special projects where at the moment we are using up to 27 strands. That means roughly about a 600-ton load applying in each and every tendon. So it is huge, but for the special projects, for a vehicular dynamic load, we need these kind of anchorages and stretching. So once the stressing is over, wait for 24 hours for anything, for any slippage or any concrete bursting. Concrete bursting I am spelling because if your concrete is not having the capacity to take this stress, to take this impact, it will give away, it will burst. So concreting is very important for post-tensioning. So once provisions, so you have to check the flow time. So this will determine the flowability of the grout material, and like how we are doing compressive strength test, you have to make cubes as well. Instead of 150 millimeter square, here you have to use 100 millimeter square cubes. So once the thick grout thick grout fills the entire conduits, then it has been taken as the work job is completed. So as I said, concreting to be very properly done, and stressing, I said it's also a very important activity which transfer the pre-stressing force to the concrete. So it is very important. At the same time, it can lead to accidents if it is not properly handled. So it is a dangerous as well. So we have to stressing need to be done through only the the trained, skilled personnel. Not anyone can do. So probable lapses, if the concrete is not adequate strength, If strength is not there in the concrete, it may give up. It may happen because of voids or because of honeycomb. It can happen. And if the post tensioning, the laying, if the conduit laying is not proper, then the cement slurry from concrete can go in. That can disturb the stressing. So that can lead to even snap. The strand can snap. And only after de-shuttering, only after stressing, you are allowed to do the de-shuttering. In post tensioning slabs, you will not be able to do the de-shuttering simply after concrete slabs. You will not be able to do the de-shuttering simply after concrete. So that I'll explain. And for this, we submit the methodology, how to execute post tensioning and all. There are some quality checking checklists. So we have to do that as well. And in COVID, how efficient this is, and very less steel, and there will be very less congestion, and the farmer will be very fast, and many things are possible. And one fine example, this is the building in Bandra Kurla complex we have constructed about 4 years back in Mumbai. In 1 month, we could able to do 10,000 cubic meter per month. 10,000 cubic meter at the level of, I think, 5th to 7th floor. We could pour 10,000 cubic meter in a month. L&T was the contractor. That has happened because of PT. Because every 5th day we used to stress and remove the farmer, take it up to next level. So in 1 month we could do 3 horizontal slabs. So it was a fantastic achievement. So it leads faster construction. Another example is Omkar Worli Tower in Worli in Mumbai. We could cast 7 slabs. You are seeing all the residential flats. So we could do 7 floor slabs in 1 month. It was very fast. Only because of post tensioning it was possible. So every 3rd day, every 4th day, we used to stress and take up to the next level, the farm out to the next level, and we could achieve this. And when you compare the cost, if the panel size is 8 meter by 8 meter, you will save roughly about 8%. And the same thing, if you are building panel size is 11 meter, minimum to 17%. I mean, cost only. Apart from that, there are many advantages like early formwork removal. So many things, better architectural freedom, many things are there. Some of these special projects want to mention, like here, Bengaluru Metro, it's a post-tension structure. This is the first time in, I think, South India. At the top, there will be monorail will be passing. At the lower level, they are open for ground traffic. So here, the segmental construction and even the construction was possible because of post tensioning. And even in Chennai airport, many of us will be visiting very often. You could see there are all precast elements cast in a different location, put it in erection and stressed together. So the deck is ready for traffic. Like many things are possible in post tensioning, and then it's fast. You don't need to keep your formwork in place. You can cast, you can precast post tensioning, and once the member is ready, shift to a truck. Even during night time, also with less traffic, erect in in that location and stress it. That's it. It's very simple and very fast. You don't need to disturb the traffic in the daytime. And one fine example we did for Indian Railways in Gandhinagar. There's a pet project of our Prime Minister. It's a very small area, small town. Gandhinagar is just away from Ahmedabad. where you could see the train is passing, and without disturbing the traffic, we could do this station building. And over this station building, there is a 7-star hotel constructed. It's the early days. So these kind of things, large span, the structures can be done in post-tensioning. That is very working friendly. And one more project I want to highlight this. It's a tank, and client's demand is all the 8 numbers of such storage tanks to be completed in 4 months. And because of post-tensioning, it was possible because the tank was constructed by slip-on technique. It's a non-stop concreting, and it is a post-tension structure. And parallelly, we could cast these slab elements. You can see all the slab, the entire slab has been cut into many pieces, and it's all post-tension slab elements. The once the tank is ready, the slab elements are also ready. So simply lift up by crane and put it in place, cover it up. The top coating concreting 75 mil thick, the second layer of the slab, it's done and it is done. So similarly, it's a pre-tensioned up slab. You can do pre-tensioning, like whatever the slab you want to make it, you can cut into small sizes. In a casting yard, you cast, you tension it, you cut it, and you shift it, and you keep it in position. Even for commercial building, you want to construct very fast, and you don't have you don't have enough space or time, you can adopt this. Once you start foundation, you start making slab elements as well parallelly. So once your columns are ready, you have to cast only the edge beams, and you can shift it to side and place it. Even many things, staircase, even staircase, you can precast, shift it, put it in place. So, and even the double T girders up to 11 meters span. Nowadays, all the IT parks, we are doing this double T girders. It is a factory made. You can cast and tension it, cut it. Even in Bangalore metro station buildings, we are doing this. And it is very simple. Only thing you have to shift it, put it in place. The platform is ready. The building is ready. The roof is ready. So this post-tensioning technology will be useful, very much efficient in this. COVID, we don't have labors. Labors are still coming from UP, Bihar, Jharkhand. So we can manage with very less workforce, and cost advantage in buildings. I have already explained. Minimum advantage you will have 7 to 8%. That is the savings you will be getting, and indirectly you will get many architectural freedom, faster cycle time, many things you will be getting in post-tensioning technique. So that's all. I think I have taken 5-10 minutes more, but that's all. Thanks, sir. Any questions you can ask?
Hello, Kavin sir, is there any questions, sir? Karthik sir? Karthik sir? Hello, Karthik sir? Sir, please wait a minute, sir.
Yeah. I'm okay.
Hello, sir. Sir, other questions ஏதா இருக்கான்னு கேக்குறாரு. யார் சார்? அதான் தெரிஞ்சது. சரிங்க சார். என்ன சார் பண்றது? பன்னீர் சாரி காணோம். பன்னீர் சார்ல தாமோதரன் சார் இருக்காரு. சார் கார்த்திக் சாருக்கு ஏதோ இதுல ப்ராப்ளம் சார் லிங்க்ல. சார் ஒரே நிமிஷம் சார் கொஞ்சம். சார் இப்போ நீங்க எது காமிச்சீங்கல்ல சார்,
ஆமா,
இதுல ப்ராஜெக்ட்ஸ் பசங்க ஏதாவது அங்க வந்து செய்யறதுக்கோ இல்ல இன்டர்ன்ஷிப் ஏதாவது அங்க
இன்டர்ன்ஷிப் எல்லாம் மேடம் அவங்க வந்து பெரிய அளவுல ஒன்னும் கான்ட்ரிபியூட் பண்ண முடியாது. பட் we entertain the internship வந்து அவங்க அது
இப்ப ப்ராஜெக்ட்ஸ் மாதிரி இப்ப ஃபைனல் இயர்ஸ் இருக்காங்க சார்.
மேடம் கார்த்திக் ஆல்சோ
I will get it here.
அது மாதிரி வாங்கிக்கோங்க. if any students are interested in இப்போ கோவிட் இருக்கனால அந்தந்த இப்போ we are doing almost in all the district capitals AIMS hospital பண்ணிட்டு இருக்கோம் மேடம். சாரி, நாட் AIMS. I think Tamil Nadu government has come out with all district headquarters some hospital they are constructing.
Okay, now they were planned to construct so many medical colleges.
Exactly.
In around Tamil Nadu
already started. Maybe I think Salem,
everywhere
பண்ணிட்டு இருக்கோம். சோ அந்த மாதிரி ஹாஸ்பிடல் ப்ராஜெக்ட்ஸ்ல கூட அவங்க போய் பார்க்கலாம் இந்த டெக்னாலஜி எப்படி ஃப்ரம் டிசைன் டு எக்ஸிகியூஷன் எப்படி பண்றாங்கங்கறத பாத்துக்கலாம். அவங்களுக்கு ஏதாவது எங்களோட ஷேர் பண்ணலாம், அவங்களோட ஒப்பீனியன்ஸ் இல்ல அவங்களோட ஐடியாஸ் இல்ல இன்னும் ஃபர்தர் அவங்க தெரிஞ்சுக்கணும்னா we can call them for a meeting. Site level visits முடிஞ்சதுக்கு அப்புறமா maybe one session of maybe 3 to 4 days they can come to any of our offices and we'll
காலேஜுக்கு தனியா இந்த மாதிரி வெபினார் வந்து காலேஜ் ரீஓபன் ஆன பின்னாடி பாசிபிளா இருந்தா நேரம் வாங்க, இல்ல இந்த மாதிரி வெபினார் ஏதாவது உங்களால கொடுக்க முடியுங்க சார்? ஃப்ரீயா இருப்பீங்க?
கண்டிப்பா மேடம். I am from Pollachi only, so mostly once in a month I will be visiting Pollachi. So
okay
அந்த மாதிரி இடத்துல we can organize it.
Okay sir, I will contact you sir, because ஏன்னா இப்ப ப்ரீசஸ் தான் எல்லா பக்கமே அட்வான்ஸ்டா போயிட்டு இருக்கேன். இப்ப இந்த கோவிட் டைம்ல எல்லாம் இப்ப வர்க்கர்ஸ் தான் சார் பெரிய ப்ராப்ளமா இருக்கு. சோ இப்ப ஒரு சின்ன ஒரு வீடு கட்டுறதுக்கே பாத்தீங்கன்னா நம்மளுக்கு எஸ்டிமேஷன் போட்டா இப்ப முதல்ல வந்து என்னன்னா ஆளுங்களுக்கு லேபரோட காஸ்ட் வந்து ரொம்ப கம்மியா இருக்கும். சோ இப்ப அந்த எஸ்டிமேஷன்ல லேபரோட காஸ்ட் வந்து மெட்டீரியலை விட ரொம்ப அதிகமா இருக்கு.
கண்டிப்பா மேடம். அதுவும் இப்ப வந்து நீங்க எவ்வளவு we are bringing them by flight. The states are not operational. Buses அனுப்புனாலும் நிறைய ஸ்டேட்ஸ்ல because the border crossing is a problem. So we are bringing by air, spending lot of money. So அப்படி இருக்கும்போது அந்த லேபர்ஸோட இன்டென்சிட்டி வந்து கம்மியா இருக்கும் இந்த டெக்னாலஜில பண்ணும்போது. So one of the metros and so அதனால இது யூஸ்ஃபுல்லா இருக்கும் மேடம். ரொம்ப யூஸ்ஃபுல்
சார். கோயம்புத்தூர்ல மெட்ரோ வந்து இதற்கு ஃபியூச்சர் பிளான் இருக்குன்னு சொன்னாங்க.
அது இந்த பிளானிங் ஸ்டேஜ் மேடம்.
ஓகே சார். இப்ப ஸ்டூடண்ட்ஸ் வந்தாங்கன்னா இப்ப வர்க் பண்ணனும் அப்படினா அந்த உங்க கம்பெனில வர்க் பண்ணனும்னா அது எப்படி சார் அப்ளை பண்றது? எப்படி
வர்க் பண்ணனும்னா மேடம் we take GET every year madam.
Okay sir.
I think we have tied up so far in 2